Hi everyone, so today we are going to learn about the application of differentiation related to related rates. So this topic is under MAT 183 Calculus. The person that involved in this project is first me myself, Nur Aisyah Hadfina binti Wahid with ID students 2024235842, and then there is Nur Amirah Dahiyah binti Syahirul with ID students 2024421992, and then lastly there is Nur Aliyah Izzati binti Razli with ID students 2024642238, and we are from CEEH 1101A. What is differentiation? So, differentiation is the process of finding the derivative of a function. It's essential a way to measure how a function's output change as its input change. The derivative if fx is denoted as f prime x or dy over dx. So moving on to differentiation rules, the basic differentiation rules that need to be followed are as below. First, sum and difference rule. Second, product rule. Third, quotient rule. And the last one is chain rule. So how do we actually apply differentiation? So differentiation was applied when determining the increasing or decreasing of a function. It is also used for determining the speed, rate of change of position with time. Moreover, based out of this topic, the derivative was used to find the maximum and minimum values of a particular function. Next, we will discuss about what is the related rates.
In the definition, related rates is a method of solving problems in which the rate of change of one variable with respect to time is related to rate of change of the other variable with respect to time. On the overview, related rates problem involve two or more variables that change at the same time, which is possibly at different rates. If we know how two variables are related and how fast one of them is changing, then we can figure out how fast the other one is changing. Well, this usually involves writing an equation relating the variable and taking the derivative of the equation with respect of time. Implicit differentiation is often used, which means like example, speed and time. Have you ever questioned yourself, how can related rates involve in daily life? They have 5 examples that is related rates is involved in daily life. This first one is understanding motion, which means related rates help explain how quantities change over time. Example, if you driving or speed change, related rates can help calculate how your distance or fuel consumption change as a result. The second one is the engineering application, which involve for engineering or science to use the related rates. Engineers use related rates to design machines or structure where different parts move together. Like example, to the calculating how fast trains move as the cable length change. The third one is weather forecasting, where the meteorologists use related rates to study how temperature, pressure, or humidity change over time to predict weather patterns. Therefore, most of the economic and business use related rates help to understand how change in one variable, like interest rates, or affect others, like investment or loan payment. The last one is medical application, where the doctors and researchers use related rates to study bodily functions, such as how change in blood flow rates affect oxygen delivery or how medication spreads in the bloodstream over time. They have 4 steps to solve the relatedness problem. The first one is to read and understand the problem carefully. Represent the information which is given and what needs to be found using mathematical symbols. The second one is to identify the suitable formula of equation that relates to known and unknown variable. Use geometric shapes, standard formulas, ratios, or trigonometric ideas, and other which is related to the solving problems. Simplify the equation using substitution to reduce it to two variables. The third step is differentiate the equation implicitly with respect to time, applying the chain rules, and incorporate any given information into the derivative. The last step is substitute all known value into derivative and solve for the unknown range.
Now, let's see the situation. Last Sunday, Aisha and Amira were excited to celebrate Alia's birthday. They decorated their dorm's room with a lot of bright balloons and set up a small cake. After singing birthday song, they realized the balloons were too high and blocking the view of the cake. So they decided to deflate them, letting the air out slowly. With the balloons now flat, they used them to create fun party hat. So the problem statement are, let's say, when they was deflating the balloons, the rate of air escape was 4 cm³ per second. The balloons also originally had 15 cm radius. Therefore, what is the rate of the balloons of the decreasing radius of the balloons? So now, here is the solution for the problem. Now we have that dV over dt equal to negative 4 cm³ per second. The volume of the balloon is equal to 4 over 3 pi r³. We need to differentiate the volume, which we will get dV over dr equal to 4 over 3 pi times 3r to the power of 3 minus 1. And we will get 4 pi r squared. Using the formula of dr over dt equal to dr over dv times dv over dt, we will get 1 over 4 pi r squared times negative 4. The answer is negative 4 over 4 pi r squared. And this can be simplified into negative 1 over pi r squared. Since r equal to negative 15 cm, dr over dt equal to 1 over pi times 15 squared, which we will get negative 1 over 255 pi cm per second. Thus, the radius of the balloon decreasing at rate of 1 over 225 pi cm per second. Finally, the conclusions. The problem demonstrates how the rate of change in the radius of a balloon can be determined based on the rate at which air escapes and the balloon's volume formula. Given that air escapes from the balloon at a constant rate of 4 cm³ per second and the radius of the balloon is initially 15 cm, the radius is found to decrease at a rate of 1 over 225 pi cm per second. These results highlight the relationship between the volume of a sphere and its radius, where the rate of change of the radius is inversely proportional to the square of the radius. Such calculation can be useful in understanding real-life scenario involving spherical objects and their rates of expansion or contraction. Last but not least, we are really grateful because we managed to complete this video presentation within the time given by our lecturer and our dedicated group members. Special thank you to our lecturer, Madam Haziza, for providing us with the opportunities to learn and guide us throughout the assignment. Last but not least, we also want to express our gratitude to our parents for their support, which leads us to work diligently. That's all from us. Thank you for watching.